You signed in, yes. Okay, so this is the bottom of the second page on the right side. At any time I find an angle that is not just regular x to the first or any variable to the first, that tells me u substitution. And probably 95% of the time we want u to be the angle because we want u to the first to be the angle. So we would want to say that u equals 2x. So du is going to equal 2dx. So in order to plug du in, I need a 2 and a dx. All I have is a dx. There's no constant of 2. That 2 must stay with the angle. So I got to create a 2, and I have to destroy a 2, and then I can rewrite this because the cosecant of 2x is going to stay cosecant, but it's going to now become u because I'm saying I want u to be 2x. So I'm sticking it in for this, and then that 2 and dx becomes my du. And now I can use my formula, okay? Now there's two ways to do this. Do you want to see both ways?
Yeah.
Okay, so I'm going to show you another way in case you forget. I think I'll show you this way first. If you forget the formula for integral of cosecant, you can always take this thing and change this to 1 over cosine u. Well, that ain't going to work. I'm sorry, 1 over sine u. I was thinking I could get there from here, but I don't believe I can. Actually, could I? Actually, I think I can, but let's see how we want to do that. I'm blank on this right now, so we'll just come over here. So we are going to plug in the formula for cosecant, which does anybody know it? Say it again. Natural log of. Now we got a little problem in our answer. Does anybody know what the problem is? That answer is not quite right. Does anybody know what's wrong with it?
It needs to be a plus sign cosecant.
Okay, there's another thing wrong with it. Anybody tell me what else is wrong with it right now? All right, I'm going to give you a hint.
Oh,
yeah, these cannot be x's because we're doing the integral of u. This has to be a u, and this has to be a u. So what that means is I'm not really done yet, because if I start up here with an x problem, I got to end down here with an x problem. So can anybody tell me what I need to do last? I can't hear you.
plug in u.
Plug in what for the u? Yeah, I got to stick my 2 x's back in here. Okay? All right. What else we got? And because I have this 8th power here, we let u be the part inside the parentheses, and then when we do du, take the power times the number in front, which is 4/3, subtract 1 from 4/3, which is subtracting 3/3 from 4/3, and you move your dx from down here over there beside it. So if you look, I've got the x to the 1/3 and the dx. I am missing 4/3, so I've got to create a 4/3 in there, and then I have to come out here and destroy a 4/3. So I'm going to have 3/4 integral, and this part in here is my u to the 8th, and then all the rest of this is my du part. So now I just do my power rule, and I add 1 to the 8th, and I put it underneath, and I get a plus c out here, and the last I need to stick this in here, and I'm going to reduce this 3 with that 9. So I got 1/12 out here. Then I'm going to stick this back in for the u. And that's to the 9th power plus some c. Anybody remember what you can do to check to see if your answers are right if you got time? Take the derivative of that answer and see that you get back. Once you take the derivative of that answer, you should get back this part in here. If you get that part back, you're right. Because remember, the derivative of c is nothing, so it goes away. We don't know what the c is unless they give us a point on the graph, and then we can find it. Anybody else got anything you want to see? 6-9. Okay, make sure your first and last names are on those and pass those up to the front. So we're going to do a long division, so you take the top thing divided by the bottom thing, just like you have been doing since 4th or 5th grade. So we're going to take, and what this is going to give me is an equal equation. It's going to give me an equal equation to the fraction, but hopefully we'll be able to do each part individually. So I asked myself, what times this gives me x squared? What times x squared gives me x squared? So I hope we know it's a 1. So I multiply that by 1, so I'm going to get the exact same thing. It's going to come down here underneath. And then one of the biggest mistakes is you have to subtract, which means change the sign of every one of these down here. So these cancel, so my remainder is negative 13. So this equal, oops, I shouldn't say equal, it should be plus, or you could put the negative from the 13 in front. Negative 13 over the divisor. Okay, so that means this thing right here equals this numerator, or this thing on top of the division symbol. So I'm going to say that that thing up here equals the integral of 1 plus negative 13 all over x squared plus 4x plus 13 dx. Now we can do the integral of 1 real easily, right? But this one's not so easy because we got a denominator. When you have a denominator of just x, you should be happy because there's a good chance it's going to be a natural log problem. But this doesn't have just x. It's got a quadratic function. So this tells me I've got to put it in one of those forms where I can do the integral of something from the quadratic. Well, I need to complete the square down here because I need to get 2 square terms down here, hopefully. So I'm going to leave this part. I'm going to write this as the integral of 1 dx. And then I got plus. Actually, I'm going to change that. I'm going to put that negative 13 out front because all of those things that have these squares on it have a 1 on top. Okay, so I'm going to complete the square on this. So I'm going to have, let me erase this. I'll have to probably move it over a little further. So you got x squared plus 4x. Then leave a little space here. Move that 13 over because we want to complete the square for this part. So what you do is you take the linear term, which is 4x. You take half of 4, which is 2, and you square it. So we have to add 4 here to complete that square, which means out here we have to subtract 4 because we want to keep this whole thing equal to what it was before. So now I want to simplify this bottom part. I'm going to go ahead and do the integral of 1, which is x. Only this minus 13 right where it is. Then I'm going to put this in factored form. So I got 1 over, and this is x plus 2 squared. Do you need me to go with how this comes about? You guys need me to tell you where x plus 2 squared comes from? Anybody? I'm going to tell you because I don't know. Maybe somebody will watch it. You got to take the square root of x, the sine of the middle term, and the square root of 4. And over here, we're going to add these two. So this is plus 9. Now, that 9 is okay, except we want it to be something squared because all those formulas have squares there. So you would rewrite this thing down again, and you would change 9 to 3 squared. So if you look at your formulas, this is the a, because a is a constant, and this is your u. And there's only one term that has u squared plus a squared underneath it, and that's arctangent. You understand what I'm saying there? So this is going to be x minus 13 arctangent, and I usually write inverse tangent because it's easier, and I just forgot what goes in front of arctangent. So I got to have 1 over a here, and then arctangent or inverse tangent. And then it's your u, which is the part inside, not the square, the x plus 2 over your a. And then it's plus some c. So the last thing you want to do is simplify this part out here in the front, which means you would write this as 13 over 3, and then everything else can stay the same. And again, You can write the word arctangent instead of inverse and tangent, it's the same thing. In other words, right here, you can write arctan. You need to know that those two things are equal. So that should be our answer. This stuff is pretty hard.